Suppose these are the coordinates given, and whatever the mass we considered, I mean that particular wire, that is symmetrically distributed around the x-axis like this. Symmetrical distribution is there over the x-axis. Then the total angle subtended at the center of the system is around, we can take 2 theta. Okay, so I'm just representing here theta degrees and here also theta degrees. Then we need to locate center of mass of this particular wire. How to identify the center of mass of system? So this is x-axis and this is y-axis. Because of the uniform distribution top and bottom, okay, the position of center of mass no doubt should lies on only x-axis. Therefore, by the symmetry rule, y COM is equal to 0. Second, let us try to imagine a smallest elemental length having dl, which is at an angle theta mean. So for solving of our problem, let us consider this is some angle alpha. So in this particular case, the value of mass of this smallest elemental value is equal to dm is equal to, so m by 2 theta into, you can write down as dl, that is nothing but m by 2 theta into length of element is nothing but what? You can write down as radius into angle at the center, or into d theta we can write down. Now in the given case, RR gets cancelled, m by 2 theta into d theta. This is the value of mass of the system. Now, hello all. As an entrance point of view, let us consider some extension. Hello all. Now let us consider the first application as an entrance point of view corner. Hello all. Let us consider the first application in the entrance examination point of view. As shown in the figure, we have something like a wire like this. This particular wire contains a mass of m and uniformly distributed over the surface. Under such a condition, the mass of the observation elemental length given by dm is equal to lambda into dl, where lambda is called as lean mass density of the wire. So length of the element is nothing but radius into angle at the center. And the value of x is equal to, you can write down as r cos alpha from the figure. However, we don't need of y coordinate. Why? Because of the symmetrical distribution, what happens, the y center of mass becomes 0, because equal distribution at bottom and upside, the y cm will be lies only along x axis. Therefore, y coordinate will be 0 in the problem. Now, let us try to find out the value of x coordinate of center of mass. Integration of x dm by integration of dm we have to do. So therefore, in the given problem, integration of the value of x is nothing but in the problem r cos alpha into lambda into r d theta divided by dm is nothing but in lambda into r d theta. We can write down in the problem. Lambda gets cancelled because of standard values, and limits are nothing but here we are taking from 0 to theta degrees already there, and 0 to here minus theta. So 0 to theta only will take, because of symmetrical effect it will be lies at exactly same position. 0 to theta only we have to take. So in the given problem, further upon substitution here, r by theta into integration of cos alpha into d theta. So limits are running from where to where? 0 to theta. Upon integrating this one, we have r sin theta by, or final answer will be theta by, can write down as what? Theta. So this is going to the final answer for the problem. Anyways, while take caring of results, okay, where we are taking, suppose the same system is given along y-axis. Suppose the same system is given along y-axis. Under such case, now suppose in the given problem, instead of x-axis, y-axis is given. Then in this problem, x COM becomes 0 and y COM, no doubt that will be equal to r sin theta by theta is the right answer for this particular case. Now let us consider third application in the problem. Welcome to the third point. Suppose there is a quarter ring given to us. Quarter ring means the angles are fluctuating from 0 to 90 degrees. Under such a condition, the mass of the finite elemental length dm considered as to be lambda into r into d theta we have to take. No doubt that is, upon resoluting the value of radius r into components, x value becomes r cos theta, and no doubt that is this y value becomes y is equal to r sin theta. Now let us try to integrate further. the value of x center of mass is equal to integration from x dm by integration dm we have to use. Upon doing this particular integration, we have the value of integration starting from 0 to pi by 2. X is nothing but r cos theta into dm is nothing but lambda into r into d theta whole divided by integration from 0 to pi by 2 we can write down lambda r into d theta we can write down. As lambda r constants, one can cancel here, and in the given problem upon solving this we have simply 2r by pi of integration cos theta will give you sin theta over the limits of 0 to pi by 2, and then it will give you simply 2r by pi. Similarly, when you try to work out for y coordinate of center of mass ycom, then integration of y dm by integration of dm, let us try to substitute the values of y and the value of dm in the given formula. We get integration of r sin theta lambda r into d theta divided by integration of lambda r d theta running over from limits where to where 0 to pi by 2. Here also 0 to pi by 2 are the limits. And then lambda r and lambda r constant quantities one can cancel. The exclusive events we can make it common. Then we have the answer 2r by pi of cos theta with a negative symbol running over limits 0 to pi by 2. Upon substituting here, again we have the values of what? 2r by pi. Therefore, for the quarter ring, the center of mass of the system lies at 2r by pi, comma 2r by pi. And for in this particular case, the center of mass lies at r sin theta by theta comma 0, and here the center of mass lies for 0 comma r sin theta by theta. So these are the three standard examples what we have to fix for the entrance point of view. Now let us see one numerical example so that you will get some idea how to solve a problem in the entrance examination. Two quarter rings having mass densities of lambda 1 and lambda 2 are formed a composite semicircular ring. We need to locate center of mass of this composite system. Let us see. The formula for center of mass of the system is nothing but xc is equal to m1 x1 plus m2 x2 by m1 plus m2 is the formula. Now the mass of the first object or this particular portion is nothing but m1 is equal to linear mass density lambda 1 into total length of the arc. Length of the arc is nothing but what? Radius into angle at the center is nothing but you can write down as pi by 2. Similarly, the entire mass of this quarter ring is nothing but m2, which is given by lambda 2 into radius into angle at the center. We can write down like this. So we got m1 and m2. In the given problem, the coordinate of for exactly this is the location of center of mass, and imagine that this is the location of center of mass. This location is nothing but 2r by pi comma 2r by pi we can write down from the previous concept. And here also this particular coordinate will be again you can write down as because left side is there, therefore minus 2r by pi comma positive 2r by pi you can write down as okay, positions of center of mass. Now upon substitution, what is the value of m1 here? You can write down as m1 is nothing but lambda 1 r into pi by 2. X coordinate will be x coordinate of system will be equal to x center of mass 2r by pi plus m2. What is the mass of another object? Lambda 2 into r pi by 2. This is the mass of second object. Located what location? Minus 2r by pi whole divided by m1 plus m2. m1 plus m2 means what you write down here? Lambda 1 plus lambda 2 into, you can write down as commonly r pi by 2 as common. No doubt that is, in the given condition, r pi by 2, r pi by 2, r pi by 2, everything going to be cancelled here. And then we can write down as, see, you can make 2r by pi, this also made common at outside. Therefore, when you make 2r by pi as common, we can write down as lambda 1. Here, with a minus symbol is there, therefore, minus lambda 2 whole divided by, you can write down as lambda 1 plus lambda 2. This is going to the x coordinate of center of mass. Similarly, let us try to find out YCOM. Same formula, nana. YCOM is equal to m1 y1. m1 is nothing but what you can write down here? Lambda 1 into r pi by 2. This is m1. y1 is nothing but positive, you can write down as 2r by pi, we can write down, plus m2 is nothing but lambda 2 into r pi by 2. This is the mass into location is nothing but again 2r by pi, we can write down, whole divided by, you can write down as what, nana? Total summation of masses is nothing but lambda 1 plus lambda 2 into, we can make common r pi by 2 as common, we can make like this. So no doubt that is, again we can able to cancel the terms like this. So r 2r pi by 2, 2r pi by 2 and r pi by 2, r pi by 2, r pi by 2, r pi by 2 will be cancelled with each other. Now in the given case, 2r by pi will be common at outside, therefore lambda 1 plus lambda 2 divided by, you can write down as what? Lambda 1 plus lambda 2 into 2r by pi as common. Denominator also lambda 1 plus lambda 2 is there, both gets cancelled, therefore 2r by pi we can write down like this. That means y coordinate will be 2r by pi and x coordinate will be 2r by pi of lambda 1 minus lambda 2 by lambda 1 plus lambda 2. Like this, in the entrance examination, you can find the center of mass of a composite system.